Welcome back class. Good day sa ato ang welcome back sa ato ang course on electricity and magnetism, and we are now down to our last chapter for this course. So nahuman na gid siya, no? So this course has a total of 9 chapters, and um, we will be having our final examination. So it's a comprehensive. So ano lang, please study sa mga lessons na atong na-cover starting from the beginning up to this very topic that we will be discussing for this session. And the exam would be easy. So yeah, it's literally easy ra jud siya because we have some factors also to consider regarding the time, and also um, due to this pandemic, all of us are adjusting. And yeah, ang importante lang ani is na lang mo'y masigamay lang jud nga take home or take away or na learn for this particular course, because I believe magamit din siya nga mga concept later on in your life as you also teach and in some other aspect sa inyong endeavor in the future. Okay, so for this chapter, we'll be talking about Faraday's law and inductance. So in the previous chapter, we discussed a lot about circuits and how is it useful in our modern devices that we use personally and are present in our respective homes. Now, these devices atong ginagamit that will actually require battery source or an EMF for current to flow in the circuit and then operate. For example, your laptop requires a battery, or maybe your rice cooker, it requires a voltage source. Your refrigerator, your microwave oven, if you have, and then your lights also in your houses, your electric fan. So those are devices that requires a source, which requires for current to flow and also and operate in your particular equipment or device. However, for most of our electric devices at home, the source of EMF or the electromotive force is actually not a battery, right? Because most of our appliances in our homes are not battery operated. It requires na isaksak mo siya sa socket, right? And that's a 220 volt source. And mind you, unlike battery, which is a direct current DC, the one that you use for your appliances is an AC current, so an alternating current na siya from a source na siya. Okay? So the source that we use is actually an electrical generating station. For example, in our case, sa Visayas, we have VECO. So VECO and other stations in the Philippines provide an electric energy to every household by other forms. So it could be from meaning ang energy o ang ato ang kuryente nga na-receive sa ato ang respective homes are actually generated from o gi-convert siya from some source to an electrical form. Okay? It could be from gravitational energy, tapos nahimo siyang electricity. So from gravitational energy to hydroelectric plant, example ana is the ILPI in Iligan City, wherein it uses waterfalls to generate electricity. So ang waterfalls, gigamit siya as a source of energy. So if you have a falls, okay, let's say nakoy falls diha, right? So from gravitational energy, it will all be converted to very big amount of kinetic energy at the bottom. So ang buhaton diri is para ma-harness na siya nga energy, they would put a turbine here, and that turbine be, will will be able will turn because of this gravitational energy from these waterfalls, right? So it will drive these waterfalls will drive the turbine to turn, and this turning from the concept of electricity and magnetism will actually generate electricity because of there's a change in magnetic field in this case. That in that case, we will going to discuss that the process. Okay, so nasa turbine diha, and then mo-generate sa electricity, and then this electricity nga ma-generate din will be distributed to every household. So basically mo na siya ang iyang source, and then naana siya yung mga process pa in between until such time maabot siya to ang respective house to provide electricity. Okay? Or it could be from other forms, let's say chemical energy in a coal or oil-fired plant, or even it could be nuclear energy at a nuclear plant. So how is this conversion of different forms of energy to electric energy that reach in our homes possible? So this is possible because of the principle of electromagnetic inductance. Okay? Electromagnetic magnetic inductance. Okay, so there would be an induced based on this term. There will be an induced uh, EMF because of this concept, the electromagnetic inductance that will happen in this particular setup. Okay, so the answer lies in the principle of electromagnetic inductance. So that is made possible because of the changing magnetic fields. In this case, na changing of magnetic fields here. So changing magnetic fields, which in turn produces a current on the conducting wire. And that current in the conducting wire, mo na siya ang mo provide na dayon og electricity. Okay? So in a power generating station, magnets move relative to coils of wire to produce a changing magnetic flux. Okay, so for let's say for in this case, we have a turbine which is let's say magnetic in nature, and then if that turbine will turn, so there is actually a change in magnetic field, and then that change in magnetic field will induce a current onto a neighboring conducting wires attached to it. Okay, so if magnets move relative to coils, it will produce a changing magnetic flux in the coils, and hence it will produce an EMF. So in principle, magnetic fields may vary in time. So ang yang strength mag-vary ba? Okay? Over time, let's say per second. Okay, so there was actually an experiment done by Michael Faraday and Joseph Henry. So the results of their experiments led to Faraday's law of induction. That is, an induced current is produced by a changing magnetic field. Okay, an induced current is produced by a changing magnetic field. Okay? So somehow related siya, 'di ba? Sa previous chapter natong i-discuss, if you have a changing uh, if you have a moving, or let's say a moving charge, let's say changing electric field, right? Changing electric field or moving charge creates a magnetic field. So somehow our universe is kind of related to this, because if you have a changing magnetic field, you create actually a moving charge, okay, in the process. So you create a current in the process. So that's how tightly related the electric field, charge, and magnetic field. Okay. So as I've said, an induced current is produced by a changing magnetic field. So there is an induced EMF associated with the induced current. Thus, a current can be produced without a battery present in the circuit, and the Faraday's law of induction describes the induced EMF. So we don't need a battery source for that. So all we need, atong recipe lang kailangan to produce an electricity, is a changing magnetic field. So kana lang siya nga concept. So we rely on that concept. Now, for this chapter, you will learn how changing magnetic field induces an EMF, and understand how Faraday's law relates the induced EMF in a loop to the change in magnetic flux, and also determine the EMF induced and its application. Okay, so this is Michael Faraday. a British physicist and chemist. So he was a very great experimental scientist. So because of his discovery, na, we are actually reaping already the benefits na provide sa ihang discovery. So all of our working devices that we enjoy right now, na it provides ease sa to ang daily life, all because of him. So thanks to him, kani si Michael Faraday. So contributions to early electricity include we have the invention of motor, generator, and transformer. And also we have the electromagnetic induction and also the laws of electrolysis. So this is specifically on the chemistry. Okay. So for example, if you have a loop of wire, as shown in this figure, so you have a loop of wire connected to a sensitive ammeter. So we have a loop of wire connected to a sensitive ammeter. So kading ammeter mo detect ni siya og current if na ay current flowing through this loop, okay, or this through this loop of wire. So when a magnet is moved toward the loop, so you have your magnet here, north and south. So if i-move na siya din ha pasulod, okay? So when the magnet is moved toward the loop, the ammeter detects a current. And ang reading niya is chosen to be arbitrarily -1. Okay, in this direction. So ang direction sa current is kani shown in red. Kani. Okay. However, when the magnet is held stationary, okay, so when the magnet is held stationary, so if that is the case, there is no deflection of the ammeter. Okay, as you can see in the reading, it's 0. So wala siya reading, meaning walay current na ni flow sa imuhang loop. Okay, so no deflection, no current, no reading sa imong ammeter. Therefore, there is no induced current even to the magnet. So walay induced current, walay reading, so walay current, as I've said. So now when the magnet is moved away, so if it moved away siya, which is opposite sa direction sa previous, di ba? Ganina is forward man to. Ang direction niya is in ani. But if the direction is in this way, meaning moved away from the loop, the current reading sa ammeter shows a positive one, so muna yung direction. Okay? So the ammeter deflects in the opposite direction, so there is current. So in other words, to sum it all up, the ammeter deflects when the magnet is moving toward or away from the loop. Okay? So maglahi lang yan direction, but the magnitude is the same. Okay? Provided nga the same ang velocity sa pag-move nimo in and ang pag-move out. Okay? So the ammeter deflects when the magnet is moving toward or away from the loop. But if the ammeter is steady, so no current siya. Okay? So ang loop mo detect siya og magnet if it's moving relative to it. Okay? So we relate this detection to a change in the magnetic field. Okay? Because if you move this magnet, so technically its magnetic field or magnetic flux through this area kaning sa loop mag-change siya, right? Kay imo man gi-move. So in this case, a change in magnetic field in a sense or technically a change in magnetic field creates an induce an EMF, so produce siya og EMF, and that also provides current, okay, sa imuhang loop. So muna kong giun ganina katong um, the the motion or moving the magnet relative to the loop actually ma-detect siya as a change in magnetic field, and if there is a change in magnetic field, then there is an induced current. Okay, and induced current because of an induced EMF. So in Faraday's experimental setup as shown here, so a primary coil, this is your primary coil, so that is connected to a switch and a battery. Now the wire is wrapped around an iron ring. So girap na siya diha. Okay? And a secondary coil is also wrapped around the ring. So this is the secondary coil. And the secondary coil is not directly connected to a primary coil. So, di sila connected, right? So, it could be, pwede na siya, insulator na siya diha nga part. Kani siya. But this one, this is a coil of wire. So, if na ay current flowing din here, because if i-close nimo na siya, so there would be current flowing through this wire. And then, ma-observe na nilang Faraday that if mo supply ka current, so na po siya ma-induce ng current here. So naa siya reading. So that's technically the principle of Faraday's law, or the induction of current. Okay. So at the instant the switch is closed, kani siya sa battery, okay, the ammeter changes from zero to a certain value in one direction. Okay, so mo change siya og kasi mo negative 1 siya, and then after that mo zero na pud siya. Okay, so the moment nga on nimo na siya or i-close nimo ang switch, okay, mo na siya, if i-close nimo ang switch, may tabo is mukalit lang siya og change, say from 0 to negative 1 and then back to 0. Okay, so that's the reading sa ammeter. So the ammeter reads 0 afterwards because there is now a steady current. Okay, so when there is no current, the primary circuit is uh, oh, 0 na siya if naka-off or naka-open ang circuit, or steady ang current. Okay? Kaya if imo na siya i-close ang switch sa battery, at first mo saka ang iyang reading, let's say mo negative 1 na siya reading, and then later on mo 0 siya because steady naman ang current. Okay? So what were his conclusions based on this experiment? Okay, well, an electric current can be induced in a loop by a changing magnetic field, because if you let a current run through it, so if na current, na ay magnetic field, right? So na ay magnetic field. So mo induce siya og, and then if you have a magnetic field at first, because ni napadagan makag current, so na siya suddenly na ay change sa magnetic field, okay, from 0 to something, so to some value, depende kung pilang amount sa current, right? So in that, if sa sugod at an instant pag close mo sa switch, na nidagan nga current diha, may flow nga current, and then because of that flow of current, momentarily na ay change sa magnetic field from 0 to some value. So that change of magnetic field induce a current sa kaning secondary coil, and that sends a reading sa ammeter. And then the moment na steady na ang current, steady na ang value, let's say from 0 to, let's say, 1 ampere. So later on, 1 ampere na siya per me. So there is now no change sa magnetic field. So wala na siya current na po din eh. So mabalik na po siya og 0. So that's the concept there. Okay? So muna kung yung ganina, at the instant the switch is closed, the ammeter changes from 0 in one direction and then returns to 0. When the switch is open, the ammeter changes in the opposite direction. So if i-close na po daw nimo, let's say this one, if i-close nimo ang switch, mo change ang value from negative 1 to 0, right? And then if imuha na po siyang i-open, meaning i-off nimo ang switch, i-open nimo ang switch, from 0, mukhaita po siya o change to 1, and then balik na po siya to 0. Because the moment nga i-open nimo ang switch, na po change sa ihang current, right? From 1 ampere to 0 ampere. So if there is a change in current, there is a change in magnetic field. And if there is a change in magnetic field, there is an induced current din here. Okay? So an electric current can be induced in a loop by changing magnetic field. So this would be the current in the secondary circuit of this experimental setup. The induced current exists only while the magnetic field to the loop is changing. So when man nag-change ang magnetic field, katong the moment nga gi-on nimo, and then after that nag-steady state ang current, and then pag-off nimo. So na-change sa magnetic field momentarily sa pag-on, o pag-off sa circuit. Okay? So this is generally expressed as induced EMF. So an induced EMF is produced in the loop by the changing magnetic field. And the actual existence of magnetic flux is not sufficient to produce the induced EMF. So magnetic flux is, ano naman na siya. So if you have your area here, let's say na ako'y magnetic field in that direction, this is flux, meaning the number of magnetic field lines crossing this or entering this surface area. So it's not enough nga na ay magnetic flux for that particular area. There must be a change in flux, okay? Meaning na ay change sa magnetic field. Okay? Na ay change sa flux dapat, meaning na ay change the number of magnetic field lines passing through it. So mathematically, it is expressed in this equation. So there is an induced, this is the induced EMF. Okay, induced EMF will produce current, right? Or this is voltage. So there is an induced EMF if there is a change in magnetic field or change in magnetic flux. Okay, so this is the formula. So this is flux. Muna siya ang symbol sa flux. So in calculus, pasabot na is d phi over dt, meaning change of flux with respect to time. Okay, so change of flux with respect to time. Or, ano lang. Okay? So, remember that the magnetic flux to the circuit is found to be, so, ang equation sa flux is just it's just the integral or the summation sa tanan magnetic field lines dotted with the area nga ni point siya sa area, right? If you have this area, it's actually basically counting the number of magnetic field lines passing to this area perpendicular to the area. Okay. So if the circuit consists of n loops, all of the same area, and if this phi is the flux to one loop, so if muna siya ang flux sa one loop, and what if daghan kay kag loop? So we have n loops, so the Faraday's law becomes this equation. So this is the general equation. This is for one loop only. This one is for n loop. Okay? So basically, ang pasabot na ani is, if you have n loops, and then each loop is naa siya ani kasi constant iyang kwan. For each loop is mo ni ang pag-change this sa iyang magnetic flux over time. Okay? So it is actually given by this whole equation. This is your induced EMF. Also, ang relationship ano niya is the greater the number of n, the greater is the induced EMF or the voltage. And also, the greater the change in flux, dako po ng EMF or voltage. So, how will you account yung sa mo pag-change sa imong flux na dako ang iyang change sa flux? One thing is, paspason mo siya og move. Okay? So, kana siya. That's one thing. Ipaspason mo ang pag-move sa imong flux kay mo dako man na ang iyang value. Another thing is, it could be i-vary nimo ang imong geometry or structure sa imong setup. Okay? So let's have an example. So a short calculation lang siya for you to be able to grasp the concept of this Faraday's law. So in a quantitative lang siya nga way. So gamay lang siya nga calculation. So take a look at this problem. So the magnetic field lines between the poles of the electromagnetic shown in figure, this one. So this example is taken from the module. Say uniform siya at any time ang imuhang magnetic field, okay? But its magnitude is increasing at the rate of 0.02 Tesla per second. So uniform ang iyang magnetic field lines, meaning distributed siya all the way, okay, all around sa imong area. So walay mas dako nga magnetic field at this point kaysa dinha. So all kay pareha siya. But ang imuha lang magnetic field is changing at this rate. So let's say from 0 second, 0 ang imong magnetic field. At 1 second, mo na iyang value, 0.02. after 2 seconds mahimo siyang 0.04 and so on. So mo ni siyang pasabot ani. Okay, mag-change, magkadako ang imuhang magnetic field. So there is now a change in magnetic field. Kaya magkadako man yung magnetic field value based given by this amount. Okay? So the area of the conducting loop in the field is found to be 120 centimeters square. Okay, this is 120 centimeters square ang area sa uh, kaning loop. Okay? So basically sa imuhang setup na ako'y magnetic field tapos na ako'y loop. Kay mura man na imong kailangan para maka-create ka og current, right? So because of the change of this magnetic field kaning imong source magnetic field, it will create an EMF, or it will induce an EMF sa kaning imong loop as shown in this setup na ay this figure na ay current in this direction, okay? Na-create diha. And that would send a signal sa ammeter so mo read siya og uh, current reading, okay? Mo read siya og something, any value of a particular current nga ma-sense ani ma-detect, and then na ay total resistance in a circuit and ammeter is found to be 5 ohm. Okay? So the question now is find the induced EMF and the induced current in the circuit. Second is if the loop is replaced by one made of an insulator, let's say if ang loop is insulator, what effect does this have on the induced EMF and the induced current? Okay? Excuse me. Okay, so we will calculate the magnetic flux first. Okay, so we will calculate the magnetic flux first using this equation. Okay, it's red puwar kayo. So we'll be using this equation, the change in magnetic flux. Because overall, ang formula is ana man, di ba? We have negative N d phi over dt. Okay? And then our formula for flux is actually magnetic field times area. Okay? That's actually ana man na siya, di ba? dA. But since uniform man ang atuang magnetic field, and then ang area is the same, uniform po siya, it's actually circular. We have B times magnetic field times area. Okay? So to get the EMF, to get this one, we need to solve first. Okay, diretso na lang. Oh, yeah, diretso na lang. So we have, ang N na to is 1, kaya isa naman siya ka-turn. Right? Isa na siya ka-loop. So we have negative dphi over dt. And then phi is given by this. So substitute na siya diha. So we have d over dt times this one. Oh, sorry. Times b times a. Okay. And since magnetic field is, the area is constant naman na siya, so pwede magawas ang area. Then we have dB over dt. And then dB over dt, given man na siya na, that's the change in magnetic field. Tara, that's 0.02. Okay, so ato na siya i-substitute diha. And take note of ang atong area is 120 centimeters square or 0.012 meters square times the given magnetic field, the change in magnetic field, we have 0.020 Tesla per second. Okay, and using a calculator, this is found to be 2.4 times 10 to the negative 4 volt. Okay, volt ang iyang unit because this is induced EMF or electromotive force or voltage. Or this is just 0.0 mahimo man na siyang ano, di ba? Kasi involved na to ang decimal place. You have 0. Point 24 times 10 to the negative 3 volt. Okay, or kanang times 10 to the negative 3, that's actually 0.24 millivolt. Okay, so muna ang iyang induced EMF. So na siya ma-induce nga EMF sa kaninga setup. Sa kani base lang na siya sa kaninga change in magnetic field. Okay, so with this induced EMF, we can then calculate the corresponding induced current. Okay, so the induced current is anak naman na gamit ta katong Ohm's law, right? V equals IR, or um, kana equals IR. So the induced current would be I equals 1, where this one, the numerator, this one is 0.24 millivolt, okay, or that's 2.4 times 10 to the negative 4 volt over the resistance of the internal resistance, which is 5 ohm. Okay, so we have 5 ohm, and then using a calculator you will get 0.048 milliamp. Okay, so that's the induced current based on this uh, problem. Now, by changing sa second question, you change daw ang what will happen to the if the loop is replaced by one made of an insulator. Kani if insulator daw ng loop, what effect does this have on the induced EMF and induced current? Okay, so by changing to a loop made of an insulator, we've made the resistance of the loop very high. So atong gi-change lang is this one is made very high if insulator. Okay, that is very high if insulator siya. So according to Faraday's law, this equation, okay, so this equation does not involve resistance, right? So wala siya nag-involve of resistance in any way. So the induced EMF does not change. So the same ra gyapon ang induced EMF, kanira gyapon nga value even if ilisdan nimo insulator ang katong loop. The same gyapon ang EMF. But the current will be smaller, right? Because if mo na siya ang induced EMF, the same gihapon, but the resistance is insulator naman dako kay siya, right? But if you have a very big number here sa denominator, this would approach to zero. That would mean walay current na mo-flow. Although naa siya EMF, but since insulator man siya, so di siya ka-produce og current. Okay? So the induced current is zero even though an EMF is present. So this situation is analogous to an isolated battery. So yun na kay isolated battery whose terminals aren't connected to anything. So naa siya EMF present, ang battery naa siya EMF, but walay current na ni flow. Okay, wala man nimo siya gi-attach onto something sa circuit. Okay? So that's the idea there. So because of this concept, daghang kani siya application gyud ang kaning Faraday's law. One is kaning the reason why we have current karon because possible nga maka-create ang electricity because of this Faraday's law. So naatay generators, right? The same na siya concept, the generator, ang kanang veco nga nag-provide sa tuwa electricity, it uses the idea of the concept of Faraday's law of induction of current. Another application niya is kana bitong sa credit card or any card, let's say debit card, mag-shopping ka sa mall, then among gamiton sa pagbayad sa counter is not cash but credit card or debit card. So, para ma-read ang information sa imong card, notice unsay buhaton sa imuhang unsay buhaton sa teller, iha ma i-swipe, 'di ba? Iha na siyang i-swipe ang imuhang card, and then ang card nga ang card imong gigamit, it contains information about you, pilay current ba, pilay balance, pilay imuhang available balance, or pilay imong utang, or sa imong name, and so on. Tan information stored na siya sa imuhang card via that magnetic something. So if you have a card, na siya magnetic strip diha. Okay, so if i-swipe nimo siya diha, so i-move, so na pag move ani i-swipe, so i-move man na siya, you actually produce a changing magnetic field because this is na siya mga magnetic moment diha. Okay, so it creates a change in magnetic flux, and change in magnetic flux will create an induced current, small current sa imuhang sa say sa certain say box ba na sa imong teller, then i-swipe ang imong card diha, right? So mo create siya og induced current, and that induced current what ma-translate na siya, or ma-decode siya as information from you. Okay, so makibaw ang ang teller if na ba kay balance available, so pwede ba ka maka-make og transaction, and so on. Okay, another is the idea on wireless charging. Okay, so sa wireless charging, nagamit niya po na siya og induction actually. So let's say if this is your charger, usually circle man na ang charger, no? Tapos na ako'y cellphone. So mo na siya idea actually sa um, wireless charging. So nagamit siya og induction. So ang buhaton is di na kailangan magsaksak og kanang wire, di ba, sa imong cellphone. Kani siyang cellphone, imo siya ipatong ani, and kani mo cellphone ma-charge na siya wirelessly. So the idea is kani siya is ang kani imong charger na siya coil of wire diha. So if kani siya mo isaksak sa socket, right? So naa siya moagi nga current diha, and that change in current will create a magnetic field. Okay, change in magnetic field. So na change in magnetic field sa kani nga part. So if mo ipatong ni siya ang cellphone sa kani nga charger, ipatong siya diha, and mind you ang kani imong cellphone sa likod ana is nasa siya coil of wire. Okay, so siya coil of wire. And kaning coil of wire dili na mo induce ang current because of the change of magnetic field here. Okay? So the change in magnetic field here will induce a current sa kaning imong coil of wire sa imong cellphone. So if there's a current, so your cellphone now will charge. Okay? Ma-charge na siya. So that's the idea sa imong wireless charging. It uses the concept of Faraday's law of induction. And some other examples pa gyud nga wherein gamit gid siya ang kaning Faraday's law of induction, induced current. Okay, so that's all for this particular chapter. So um, short overview lang gini siya, introduction. So there's more to it pag yun ani when you go into higher physics. But for now, this is enough to give you a background on Faraday's law of induction and how is it useful in today's society. Okay? So for this particular chapter, wala tay problem set. Yay! So wala problem set. All in all, uh, total of 8 problem sets lang, but 9 taka chapters, okay? So see you on final exam na siguro. So I'll just make an announcement sa atong Google Classroom, and I will also inform the mayor so that your mayor can inform you. Okay? So ano lang, review everything from the beginning to the end up to this chapter na akong i-discuss. And I promise nga I'll just make the quiz or the exam easy. Kung unsa ato na-discuss, ato na-cover, mao pod na ang ako ang ihatag sa inyo nga exam. So wala tay problem solving, multiple choices lang tanan. Okay? So hope to see you on finals, and do good and amping mo always, and stay safe and God bless. Thank you.